Hi Year 12s, in this video we're going to look at the light-independent reactions that occur in photosynthesis. So this is the same key knowledge point from the last video, but now we're looking at the light-independent stages of photosynthesis in those C3 plants. So same success criteria, I've just changed the word light-dependent to light-independent. So you need the inputs, the outputs, or the reactants and the products, the enzymes and the coenzymes, I've written that twice, I'm going to leave that in there. Basically, you should understand them between both the light dependent and the light independent stage and how it cycles between them. So this slide is straight from the last PowerPoint as well. We're now looking at the light independent reactions that occur in the stroma, so in this space in the chloroplast. So the stroma is the empty space in the chloroplast. So I've left the thylakoid membranes there. I've just faded them out a little bit for you so that you can see that they're there, but we're looking at the space around them. So rubisco is an enzyme that's essential for this reaction to occur. It's named in the study design as an enzyme we need to be able to understand. Without it, the light independent reactions cannot occur. So carbon dioxide is another input of photosynthesis, and it is used up in the light independent reactions. And the goal is to take that carbon dioxide and make it into glucose, that C6H12O6 molecule that you need to make sure you remember the formula of. If you look at glucose, it has carbons and oxygens, which come straight from this carbon dioxide molecule, but it also has hydrogens. Those hydrogens come from that NADPH molecule, or that coenzyme that was produced in the light-dependent reactions. So that's now, it was a product of the light-dependent reactions. It's now an input or a reactant in the light-independent reactions. It, hide my little head there, it creates NAD+, because that hydrogen atom is offloaded. It's put here into the glucose molecule, and then the NAD plus coenzyme is able to then exit and be recycled back through the light dependent stage of photosynthesis. That ATP molecule that was produced is also used up in this reaction because it takes a lot of energy to build glucose, and it is recycled back into ADP and inorganic phosphate, which again is now an input back to the light-dependent reactions. So in summary, this reaction is taking carbon dioxide and making glucose. It requires ATP and NADPH from the light-dependent reactions for that to occur. Rubisco is the enzyme responsible for that stage of photosynthesis. Should also note that you might also see the light independent reactions referred to as the Kelvin cycle. That's another name for this stage of photosynthesis. Here's another slide that you would be familiar with from last year that explains the light independent reactions. Feel free to, using some written text, feel free to pause this slide and have a read through and take some notes if you would like. In summary, this diagram here is straight from your textbook, and it shows the location of both stages of photosynthesis. So the light independent reactions happening in the grainer on the thylakoid membranes. Its inputs are water and sunlight. Its inputs are also NAD plus and ADP and inorganic phosphate that's recycled from the light independent reactions into the light dependent reactions. When a product of the light dependent reactions is oxygen, or the outputs are oxygen, and now an ATP molecule and NADPH, they've been loaded up, coenzymes ready to go into the light dependent independent reactions. An input for the light independent reaction obviously are those coenzymes. It's also carbon dioxide. Together, they are all able to produce glucose with the help of the enzyme Rubisco. In previous study designs, you needed to know the numbers associated with those coenzymes, so the NADs and ATP. For photosynthesis, you do not need to remember the number of NAD plus and NADP molecules, but you do need to know that they exist and that they are important and their roles in those both of those reactions. You need to know the inputs and the outputs of both and the location of both of those reactions as well. Now have a read through this question and see if you can have a go at finding the correct answer. So the correct answer there was C. 69% of students were able to get this correct, that the light-dependent stage produces ATP for use during the light-independent stage. So that ATP molecule is produced in one stage and it's taken to the light-independent stage to be used. Next question. Excellent. So the answer is B. Rubisco is the enzyme that's located in the stroma of the chloroplast. We know it must be there because it helps with the light-independent reactions to occur. It should be noted that this particular question was written when Rubisco wasn't part of the study design. You didn't need to know that it was involved in the light-independent reactions, which is why that hint's been given to students. You should know that walking into your exam. Have a look at this one. This is illustrated, both reactions illustrated in a way that you've not seen before. So the correct answer is B. 53% of students were able to get that correct. The arrows in the middle of each diagram indicated the direction of the reaction. So they were all moving from top to bottom. Option C was, I guess, the distractor in that reaction. It had one of the options reversed, which is why one of the reactions reversed, which is why it's incorrect. The correct answer there is B.